Hi everyone, this is lesson 2-3. We're going to be discussing the remainder and factor theorem in this lesson. However, for this video, the learning target is for students to be able to divide polynomials using long division and synthetic division. So before we get to the remainder and factor theorem, we first have to learn how to divide polynomials using both long and synthetic division. Okay, so we've already talked about, in the previous video, dividing polynomials using long division. This time we are going to be dividing by a polynomial of degree 2 or higher. So remember that degree 2 means that 2 is the highest exponent, or the degree actually is the highest exponent. And so in this example, we are going to be dividing, or our divisor is going to have a highest exponent of 2 or even higher than that. In the previous example, in the previous video, we only divided by a polynomial of degree 1. So, moving forward, we are going to divide this cubic function right here. This is our f of x function. And this right here is our d of x function. That's our divisor. And we're going to divide those two functions using long division. So I'm going to take x squared minus 5x plus 6, and I'm going to divide that into x cubed minus x squared minus 14x plus 4. And I just want to double check to make sure that I am not missing any terms in my dividend. Make sure that all exponents are accounted for. So looking at my dividend, I have a power of 3, because we have a cubic function here, power of 3, power of 2, power of 1, and then here at the end we have a constant, which really that 4 has an x to the 0 power next to it, but we never have to write x to the 0 power because x to the 0 power is really just 1, and 1 times 4 is 4. So they never put that x to the 0 on the constant. So now we're ready to set and divide these two polynomials. So I'm going to start by dividing x squared into x cubed. And if I look at that, x cubed divided by x squared is equal to x. And so just like in the previous video, since my quotient here is x, I'm going to record that over the top of the x term in my dividend. So x to the first has to align with x to the first. And what I'm going to do from here is I'm going to multiply this x to the first by all of these terms in my divisor. So if I multiply, first of all, x squared by x, I'm going to get x cubed. If I multiply x by negative 5x, I get negative 5x squared. And if I multiply x times 6, I get positive 6x. And I'm going to subtract there, and if I subtract these columns like I always do with long division, x cubed minus x cubed is going to give me nothing. Negative x squared minus negative 5x squared. We have a double negative here, so that's really like adding 5x squared. So we're going to end up with a positive 4x squared there. And then we have negative 14x minus a positive 6x, which is negative 20x. And we're going to carry down the positive 4. And we're going to start the process all over again. So we are going to go ahead and divide x squared into 4x squared. So if I divide 4x squared by x squared, that gives me a positive 4 because the x squareds cancel out. So I'm going to record a positive 4 up here. And now, again, I'm going to distribute this 4 all the way to every term in my divisor. That gives me 4x squared minus 20x plus 24. I'm going to subtract. And when I subtract these columns, the 4x squareds cancel. Negative 20x minus a negative 20x. Remember, minus a negative is really like a positive. So we're really adding 20x to negative 20x. So those also cancel. And in the end, I get 4 minus 24. And if I write out here 4 minus 24, that gives me a negative 20. So my remainder here is negative 20. And in the end, I'm going to just erase up here some work so I can add my divisor at the end of my quotient. We have a 4 here, and then we're going to add the remainder of negative 20 over, remember the remainder always has to be written over whatever our divisor was. In this case, that's x squared minus 5x plus 6. So we have our quotient here. Our answer is x plus 4 minus or plus a negative 20 over x squared minus 5x plus 6. So just to reiterate our answer here for the previous problem, we got a quotient of x plus 4 minus a remainder of 20 over x squared minus 5x plus 6. In the previous slide, I did write this minus as plus a negative, which remember adding a negative is the same as subtracting. All right, it's time for you to try one on your own. This is our check for understanding here. I want you to divide 2x to the 4th plus 9x cubed plus x squared minus x plus 26 by x squared plus 6x plus 9. Now you have 4 choices here, A, B, C, and D. Go ahead and work out the problem and select an answer A, B, C, or D. Make sure you pause the video while you're working out the problem and then come back and check your answer afterwards. Okay, so in the last example, we were asked to divide the polynomial 2x to the 4th plus 9x cubed plus x squared minus x plus 26 by x squared plus 6x plus 9. So this is our divisor, this is our function, which is our dividend, and we can go ahead and divide x squared plus 6x plus 9 into our dividend, which is 2x to the 4th plus 9x cubed plus x squared minus x plus 26. And when I go ahead and divide this, I just want to double check. It's always good for you to double check your dividend to make sure you're not missing any terms. Make sure that every exponent is accounted for and that they don't skip a term or leave one out. So we have x to the 4th power, x cubed, x squared, x to the 1st, and then our constant, which actually has an x to the 0 next to it. So going forward here, we're going to divide x squared into 2x to the 4th. So if I take 2x to the 4th divided by x squared, I actually get 2x squared. So I'm going to record the 2x squared above the squared term in my dividend. Notice that those powers align. They're right on top of one another. And then we are going to go ahead and multiply all of this divisor by 2x squared. So if I multiply 2x squared times x squared, I get 2x to the 4th. 2x squared times 6x is positive 12x cubed. 2x squared times 9 is 18x squared. And I'm going to subtract those columns, and the 2x to the 4th cancel. 9 minus 12x, 9x cubed minus 12x cubed is negative 3x cubed. X squared minus 18x squared is negative 17x squared, and I'm going to carry down the negative x. Now, if I divide x squared into 3x cubed, I take negative 3x cubed divided by x squared. That gives me negative 3x. So I'm going to record that. I got to erase just a little bit here so that I don't overlap my answer. And we said that we get negative 3x here. Again, I'm going to multiply this negative 3x by each of the terms in my divisor. So I end up with negative 3x cubed minus 18x squared minus 27x. Okay, again, I multiplied all of these terms in my divisor by negative 3x. So when I subtract these columns, the 3x cubes cancel. I'm left with x squared here. Negative 17x squared minus a negative 18x squared is x squared. Negative x minus a negative 27x is positive 26x. And I'm going to carry down the 26 at the end. So, first thing I'm going to do here then is divide x squared into x squared, which gives me a positive 1. And I'm running out of room at the bottom here, so I'm going to have x squared plus 26x plus 26. And when I take positive 1 and multiply it all, each of my terms in my divisor by 1, I get x squared plus 6x plus 9. And if I subtract these columns, the x squareds are going to cancel. I'm left with 20x and 26 minus 9 is going to give me 17. So this is my remainder, and remember we always have to put our remainder over our divisor. So on the next slide I'm going to write out the answer because I'm running a little out of room here. So my final answer then is 2x squared minus 3x plus 1 plus my remainder, remember, was 20x plus 17. And if I divide that by my divisor, which was x squared plus 6x plus 9, we have our final answer. Now, to look at the answers from the multiple choice, this answer corresponds with letter A. So A is our answer to the check your understanding question. All right, so now I'm going to teach you synthetic division, which many students think synthetic division is so much faster and easier than long division. They're both important, so you need to know how to do both. So it's not like we can just go ahead and forget long division, because you're going to need to know how to use both long and synthetic division with polynomials. But here are some steps to synthetic division. The main difference between synthetic division and long division and why it becomes so much easier is because you can drop the variables. And synthetic division is only used, the only thing we use in synthetic division is the coefficients of each term. So, with synthetic division, the algorithm for synthetic division is to divide a polynomial, so f of x, by a factor x minus c, and then complete each of the 4 steps that they have outlined. So the first step is to write the coefficients of the dividend in standard form, and write the related 0, c, of the divisor in the box, bring down the first coefficient. Okay, so just to look at this example, here's a function. They're asking us to divide this cubic function by x minus 3. Okay. So notice that they've written the coefficients in standard form, which means in order of decreasing power or descending power. So 6 goes first, then negative 25, then 18, and then 9. Like I said, we don't use any variables. We drop the variables, and we're just looking at the coefficients or the numbers in front of each term. Now, our divisor in this case becomes the related 0, c, of the divisor x minus c. So we want to know, we know our divisor is x minus 3, but we need to know what the 0 of that divisor is. So if I set x minus 3 equal to 0, we get x equals 3, hence why they have put a positive 3 in the divisor box. Now the next step is to bring down the first coefficient. So notice that there's this arrow and they just carry down the 6. We are always going to carry down the first coefficient. Okay, so once we've carried down the first coefficient, we move on to step 2. We're going to multiply the first coefficient by c, which is our divisor up here. So they multiplied 6 times 3, which gave me this 18 here. Now, the difference between so we're going to record the product under the second coefficient. So here's our second coefficient. We recorded the 18. The main difference between synthetic and polynomial division is instead of subtracting the columns, we actually add the columns together. So we're going to add negative 25 plus 18, which gives me a negative 7. And then we're going to start the process over again. And we are going to repeat steps 2 and 3 until we reach a sum in the last column. So because we multiplied 6 times 3 to get 18 here, now we are going to multiply negative 7 times 3, which gives us a negative 21. And in negative 21, if I add that to 18, that gives me negative 3. Remember, again, in synthetic division, we add our columns. And negative 3 times positive 3 gives me negative 9. And when I add the last column, that gives me a 0. Now, the last number in synthetic division is always a remainder. In this case, our remainder is 0, so the polynomial x cubed minus 25x squared plus 18x plus 9 is evenly divisible by x minus 3. Now, these numbers right here represent the coefficients of our quotient. So after the remainder, this negative 3 represents the constant, then negative 7 represents the x term, and 6 represents an x squared term. So as we move from right to left, from the remainder to the left, each term grows in degree. So the negative 3 would be x to the 0 power, negative 7 right here would be x to the first power, and 6 would be x squared. So our actual quotient to this problem is 6x squared minus 7x minus 3, and there's no remainder. So we would just add plus 0 over x minus 3, which is 0 anyways. So we're going to go ahead and look at an example using synthetic division in the next slide. Okay, we are going to divide synthetically the function 2x to the 5th minus 4x to the 4th minus 3x cubed minus 6x squared minus 5x minus 8 by x minus 3. Now remember, with synthetic division, we have to find the 0 of our divisor first. So if we take our divisor, which is x minus 3, and set it equal to 0, we can find the 0 by finding x, or solving for x. So if we take x minus 3 equal to 0, that implies x equals 3. And in the divisor box, I have a 3. Now, what I want to do for the top row here across is I only use, remember with synthetic division, we never use the variables. We only use the coefficients of each term. We need to make sure that we have every term accounted for, and that if one is missing, that we put a 0 in its place. So looking at our dividend up here, 2x to the 5th power is accounted for, the 4th power is accounted for, x cubed is accounted for, x squared, x to the 1st, and then our constant. So we're not missing any terms here, so I'm just going to copy down what those coefficients are. 2, negative 4, negative 3. I need my eraser over here. I'm going to erase this work so I have some extra room. Negative 6, negative 5, and negative 8. And I'm going to carry out my synthetic division, first of all, by carrying down the first number. The first number is always carried down. So we're going to carry down the 2. And then I take that number and multiply it by my divisor, which is 3. So 2 times 3 gives me 6. I record that 6 underneath the next number. And in synthetic division, the main another difference between synthetic and polynomial long division is that we add the columns rather than subtract. So I have 6 plus negative 4, which is 2. Then I'm going to take this 2 and multiply it by the divisor. 2 times 3 is 6. If I add this column here, I get 6 plus negative 3 is positive 3. I'm going to multiply the 3 by the divisor. So 3 times 3 gives me 9 this time. When I add this column, I get a positive 3. I'm going to multiply 3 times 3, which gives me 9. When I add this column, I get a positive 4. And 4 times 3 is 12. And when I add the last column, 12 and negative 8 make a positive 4. Now, here's what I have. These are my numbers for my quotient. The last number always represents our remainder. If our remainder is not 0, what that means is that this polynomial is not evenly divisible by x minus 3 because we had a remainder of 4. And if we look from the farthest number to the right and move our way to the left side, the next number is our constant in our quotient. Then we have x to the first, x squared, x cubed, and x to the fourth. So as we move from the right to the left, so as we move in this direction, each term increases in degree. So remember, our constant is really just x to the 0 power, but x to the 0 is 1, and 1 times positive 4 would equal 4. So I'm going to go ahead on the next slide and write out our answer and substitute back in these variables that we had taken out while we were doing the synthetic division. So our final answer from the previous example is 2x to the fourth plus 2x cubed plus 3x squared plus 3x plus 4 with a remainder of 4. And remember that we always write our remainder over our divisor, and our divisor was x minus 3. All right, so we're going to look at another example of synthetic division here. This time we have a little bit different divisor. Our divisor this time is 4x plus 1. So if I find the 0 for the divisor, I set 4x plus 1 equal to 0. That implies 4x equals negative 1 if I subtract 1 from both sides. And when I divide by 4 on both sides, x equals negative 1/4. So this time I am going to go ahead and put negative 1/4 as my divisor. Again, I'm going to double check my dividend right here, this function that we're dividing into. Make sure we have no terms that are missing. So we have an x to the fourth, an x cubed, an x squared, an x to the first, and a constant. So we have 8, 38, 5, 3, and 3. We're not missing any terms. We didn't skip over any terms like every term is accounted for, every power is accounted for, because starting with 4, it descends by 1 each term. So we have 4, 3, 2, x to the first, and then remember this is really x to the 0 at the end. Now, if we start our synthetic division, we start by carrying down the 8. 8 times negative 1/4 is negative 2. I'm going to add my columns. 38 minus 2 is 36. 36 times negative 1/4 is going to give me negative 9. If I add 5 and negative 9, I get negative 4. Negative 4 times negative 1/4. So if I multiply negative 4 and negative 1/4, I get a positive 1. If I add my column, 3 plus 1 here gives me a positive 4. And when I multiply this 4 by a negative 1/4, 4 times negative 1/4 is going to give me a negative 1. So when I add this last column, 3 and negative 1 give me a remainder of 2. So again, because we don't have a remainder of 0, what that means is that this polynomial is not evenly divisible by 4x plus 1. And if I look at these values at the bottom of my synthetic division, they give me the coefficients of each term in my quotient. So this is my remainder, constant, x to the first, x squared, and x cubed. Remember, as we work from right to left, each term grows in degree or increases in degree, and our constant is always really x to the 0 power. So what we have here, if we write out our answer, our final answer is 8x cubed plus 36x squared minus 4x to the first power plus 4 plus a remainder of 2. And remember, our remainder always has to go over our divisor. It has to be divided by our divisor, which was 4x plus 1. So our final answer then is 8x cubed plus 36x squared minus 4x plus 4 plus 2 over 4x plus 1. All right, it's time for you to check your understanding of synthetic division. I need you to find the quotient for 6x to the fourth minus 2x cubed plus 8x squared minus 9x minus 3 when you divide it by x minus 1 using synthetic division. You have 4 choices, A, B, C, and D. Go ahead and complete your work in the space provided here or on your paper, and then select your answer. All right, so we're going to go ahead and complete this synthetic division. Again, the 0 of our divisor is the most important thing to do first. So if we find the 0 of our divisor, we get positive 1. If we set up our coefficients here, we're not missing any terms. So we have 6, negative 2, 8, negative 9, and negative 3. When I carry out my synthetic division, I always carry down the first number. So I carry down the 6, multiply the 6 by the divisor. That would give me a positive 6. I record that under the negative 2. Remember, with synthetic, I add my columns. If I add negative 2 and 6, I get positive 4. Then I multiply the 4 times the divisor again. 4 times 1 gives me positive 4. I add my column, I get 12. Multiply 12 by our divisor, which again is 1. So 12 times 1 is 12. Add my column, and 12 and negative 9 give me a positive 3. 3 times positive 1 is positive 3, and I get a remainder of 0. So since my remainder is 0, 3 would be my constant, 12 would be my x to the first term, x squared term, and then x cubed is the 6. So my final answer would be 6x cubed plus 4x squared plus 12x plus 3. And I don't have to add anything beyond that because our remainder here was 0, which means x minus 1 is divided evenly into this quartic function, 6x to the fourth minus 2x cubed plus 8x squared minus 9x minus 3. Which means that the answer to the multiple choice was D.